So this morning we are going to do the general form for the Taylor series, which will also lead us into the Maclaurin series. So Taylor and Maclaurin series is what we're doing next. Now, the first thing we're going to do is write down the formula. And you're going to look at the formula, you're going to say, what? And you're not going to understand it at all. But it's okay, because we're going to put it together in something that makes a whole lot of sense and makes it a whole lot easier. I do want you to see the formula though, so that way, in case they put it on some sort of free response, you understand what it is that you're looking at. So, what you're going to do from a Taylor series is you're actually going to create a polynomial equation from a function. So they're going to give you some sort of function. And every function can be represented as a polynomial function. And I know that sounds weird, but we're going to take a look at it, and I'll even show you in the calculator how it looks and how you get closer and closer and closer the more terms that you have in the polynomial function. So the terms of the polynomial function, now we have these little squiggly lines because it's not equal to, it's approximately the function at A. Now, what is A? We'll talk about A, but it's where it's centered. So it's like you got to have a starting point for the equation. And we'll talk about what that is as well. Plus the derivative at A times x minus a, plus the second derivative of a times x minus a squared, all over 2 factorial, plus the third derivative of a times x minus a cubed, over 3 factorial. Coming down here, the fourth derivative of a times x minus a to the, you got it, the fourth, over 4 factorial. And then it just keeps on going. Fifth of a times x minus a to the fifth over 5 factorial. And then, of course, at the very end, the formula you've got the function with the derivative to the whatever, 2, 3, 4, 5, blah, 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 of a, times x minus a to whatever that number was, divided by the number factorial. Okay? So this right here is the formula for Taylor series. So it's the general form for Taylor series. Now I told you it was going to look way, way, way confusing. You're going to be like, what on earth are you talking about? We've never taken anything of derivative to the fifth and all this factorial stuff. What is it exactly that we're going to have to do? Don't worry, it is fine. A, remember, is where the equation is centered. Okay? It's where the equation is centered. If the equation is centered at 0, it's called a Maclaurin series. If equation is centered at 0, it is called a Maclaurin series. We can write series. Okay? So basically Taylor and Maclaurin were doing the exact same thing, except that one was centered at 0 and the other one is centered somewhere else. Kind of like Rolle's theorem and then the mean value theorem. Those were really similar to each other. Mean value theorem, remember it says that if you've got, the slope of the secant line, you've got some other point in between those 2 points where the slope of the tangent line is equal to the slope of the secant line. Well, Rolle's theorem was that if you had 2 points that were equal to each other in y value, then you were going to have some point in between where the slope was equal to that 0 as well. So it was just sort of like a special 0 case. So that's the exact same thing here. We've got Maclaurin and Taylor doing very similar things, just centered at different spots. Alright, so let us go ahead and get started with our first example. Ooh, actually before that, well, all right, let's write our first example and then we'll take a look at how we're going to be doing this. So they're going to tell us to create the Taylor / Maclaurin series centered at 0, which means it actually makes it a Maclaurin because it was centered at 0. But really and truly, they'll call it Taylor Maclaurin because you're going to do the exact same thing no matter what. You don't have to change what it is you're doing, whether it's a Maclaurin or whether it's a Taylor. It's just going to change the letter A, and it'll make it 0 in this case. And we're going to find it centered for sine of x. And we would like to find 4 terms. And we're actually going to end up finding more than 4 terms because I want to show you in a calculator what happens and what it is that Taylor and Maclaurin actually found out and what they can actually do. All right, so on a separate sheet of paper, I went ahead and I made a Taylor-Maclaurin chart. You probably want to hit pause for a second and go ahead and copy down what I've got written, and then I'll explain it to you. All right, so let me explain what's going on. Taylor-Maclaurin chart. What you're going to do is you're going to have a function, and you're going to put the function right here. Then you're going to derive it for the first derivative, second derivative, third derivative, fourth derivative, fifth derivative, however many terms that they need. So if they wanted the first 4 terms, you might only need the first 4 derivatives. In the case of our last one with sine, we're going to need more derivatives because you'll find out that we're going to get things that equal 0. Now, A is going to equal whatever it is up here, okay? So in our first example, A is going to equal 0. In an example today, A will equal 1 or 2 or 5 or something like that. What you're going to do is you're going to evaluate the function at A. So you're going to evaluate the first function at A. Then you're going to evaluate the derivative at A. Then the second derivative, then the third derivative, then the fourth derivative, and so on and so forth. That's this column. Now, after that, you're going to fill in all the extra pieces of the equation. So you're going to have a 1 right here. Then you're going to have an x minus a to the 1. Then you're going to have an x minus a squared over 2 factorial. X minus a cubed over 3 factorial. X minus a 4 over 4 factorial. X minus a 5 over 5 factorial. And of course, it's going to keep on going and going and going. This number that's in this column is just going to be our leading coefficient. It's just going to be a number. So it's going to be the number times 1. The number times x minus a. The number times x minus a squared over 2 factorial. The number times x minus a cubed over 3 factorial. And so on and so forth. Okay? So let's go ahead and take a look at our first one. What we're going to do is we're going to make our chart. Okay, you've got your function. And you've got that a is equal to 0. Okay, we've got our function and we've got that a is equal to 0. Now, the function they wanted us to find our Taylor series for was sine. Okay, so this is our function. This is our f. Now, we're going to go ahead and find the first derivative, the second derivative, the third derivative, and then the fourth derivative. Now, notice that I did 1 little tick mark, 2 tick marks, 3 tick marks, and then I just went to a 4. I mean, come on, how many tick marks are you going to draw before you're done, right? So we just switch. Once it gets to 4, we do 4, 5, 6, 7. Instead of doing 1, 2, 3, 4, 1, 2, 3, 4, 5, you'd be here forever writing all those little marks. All right, so let's go ahead and find the derivatives of all these things. So derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is positive sine. You're basically just making our little chart like we did when we were learning the derivatives of sine, cosine, and so forth. All right, so now we want to evaluate each one of these functions when x equals 0, okay? A equals 0, a is going to be plugged into this x. So what is the value of sine at 0? Well, it's 0. What is the value of cosine at 0? Well, that's 1. What's the value of negative sine at 0? Well, that's back to 0. Negative cosine at 0, well, cosine of 0 is 1, so it'll be a negative 1. Then you're back down to 0. Now, here is the problem with this one, okay? When you're looking at this one, you're only going to have 2 terms because you've got all these zeros along the way, but you are still going to start it the exact same way we did over here. Except we don't have to worry about our a because our a is 0. So what are we subtracting? X minus 0? Well, we're not going to write that. We're just going to write it as x. So the first one is 1. The second one is x minus a to the 1. So x minus 0 to the 1. We're not going to write that. This next one is x minus 0 squared. So x squared over 2 factorial. The next one is x minus 0 cubed over 3 factorial. The next one is x minus 0 to the 4th over 4 factorial. And when we go ahead and we write our equation, f of x is approximately, well, 1 times 0 is just 0. 1 times x is x. This 0 is gone. So all of these zeros aren't really working for us. So we only have x minus x cubed over 3 factorial. So when I say find the first 4 terms, we've actually only found 2 of them because of all these stupid zeros. So we have to go on and we have to add some more things so that we can go ahead and get the rest of our thing. Now, it is going to start doing a pattern, so you'll see the pattern in a little bit as well. All right, so after sine is back to cosine, then we've got negative sine, then we have negative cosine. Let's see what we got. This is a positive 1, this is a 0, this is a negative 1. So this one will be x to the 5th over 5 factorial, x to the 6th over 6 factorial, and x to the 7 over 7 factorial. We don't care about that one. So our next term is plus x to the 5th over 5 factorial minus and x to the 7th over 7 factorial. Now, are we done? Of course not. You can keep going and going and going and going. But we're done for what we need right now. Now, what I want to do is I want to show you a graph in the calculator, and I'm going to use this over here. So let's say we'll make sine x the blue one. Okay? Sine x is the blue one. Let's go ahead and graph. So you see the graph of sine x. Now, what I'm going to do in the next one is I'm going to show you in red what these things happen and what happens as you add terms. So if we just had, say, x, you've got x. Look how it's centered at 0, and look at how it actually overlaps right there. Now, what if I took this same equation and I said x minus, and I've got the x cubed over 3 factorial. Now, factorial can be found under math. I think it's probability number 4. So I go ahead and graph. Now watch what happens, and this is going to take a little tiny bit here. But you've got your blue sine curve, and now we're going to do the red one. Now look what happens when I added another curve. Interesting. So now it started to curve a little bit more, and it's doing more of the sine curve. Now, is it exactly? No, but it's getting closer. Now you can imagine, as I keep adding things, this thing's going to get closer and closer and closer to what we actually have as sine. And the more of these terms that you put in, the closer it is going to look to the actual function. Now, sadly, we have to wait as this thing does its graphy thing. There's your sine curve. Now here's 3 terms. So notice, oh, this time it comes to the bottom, but then look at how it matches up with the curve for a little bit longer. It still doesn't match the curve exactly, but it does a little bit more. Now, I'm going to do just one more. So we got minus x to the 7th over 7 factorial. Boom. So this will be the last one that we do. But as you can tell, as you go further and further and further along, you're going to get closer and closer and closer to the actual function. You're going to see it's going to come from the top this time. There's our red one. So now it's matching a function right there, and look, it matches, 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 and it's going to match all the way to there. So we're getting closer and closer and closer to this thing matching the sine curve. It's pretty exact between -3 and +3, and we only have 4 terms. So imagine, as you add more and more terms, we could get this thing to match all the way from -10 to +10 pretty easily. Because you also have the pattern. You had a +1, then a -3, then a +5, then a -7. The next one is going to be a +9. Then you'll have a -11, +13, -15. It's odd numbers, and it's just going positive, negative. So it's getting bigger and bigger and bigger as we go along. And so as you add those terms, that's what the Taylor series does. It takes a function like sine x, and it turns it into a polynomial equation. Okay? All right, let's look at the next one. I think I have enough room at the bottom of this page for this one. Number 2, create the first 5 terms of Taylor-Maclaurin centered at 0 for y equals e to the x. Okay? All right, so we've got our function. We have a is equal to 0. And our function is e to the x. So first, second, third, fourth, and fifth, because we want to do the first 5 terms. Okay? So what's the derivative of e to the x? This one's nice and easy, because the derivative of e to the x is e to the x. Now, when you start getting a chain rule going, that makes it a little bit harder. So the more you have to do with chain rule, or if you have fractions or a square root, and we are going to see some of those. So these can get a little more ugly, but we're just starting off nice and easy so that we can get the process of things going on. Now, we evaluate e at 0. Well, e to the 0 is just 1, so all of these are just going to be 1. Now remember, it starts at 0. Well, your exponent starts at 0. So x to the 0 is just 1. Then x minus 0 to the 1 is just x. X minus 0 squared over 2 factorial is x squared over 2 factorial. X minus 3 cubed, or sorry, x minus 0 cubed is x cubed over 3 factorial. Then you have x4 over 4 factorial and x to the 5 over 5 factorial. Now, I like to write it here before I write my equation. Now, in an AP problem, you can't stop right here. If you stop right here, they're going to say, what is that? They don't like to look at tables. They like to look at things all written out. So you have to say f of x is approximately 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x4 over 4 factorial. And actually, we didn't need this one because this is 1, 2, 3, 4, 5 terms, and they wanted the first 5 terms. So this would have been the 6th term. So we didn't need it. We've got our 1, 2, 3, 4, 5 terms. Now again, we could graph this thing. Maybe I only graph this one. See what we've got here. You've got e to the x, and then we have 1 plus x squared over 2 factorial. Let me just go ahead and do plus x cubed divided by 3 factorial plus x to the 4th divided by 4 factorial. All right, so e to the x is going to be the first one that's graphed. So there you go, you can see it. And then the red one is going to come up and it's going to show you what our 5 terms looks like compared to this. So look, it's off, but oh, it joins in. And oh, it's so super close. I mean, look, it kept with it all the way over here. It just messed up over here because you're going up to the fourth. So it has to look kind of like a parabola. So what's going to happen is the more terms you have, this is going to come out a little bit further. And so eventually you've got the whole screen looking like e to the x. All right, let's look at the next one. So the next one is a little bit harder as far as derivative goes, but we're not going to go as far. So I'm going to give you that f of x is equal to 1 over the square root of x plus 1. So now you can see that we've got something that's a little bit harder to take the derivative of. And I'm going to write a second degree Maclaurin polynomial. Now, this time I just said Maclaurin, which means you know that it's a equals 0. Okay, if I say Maclaurin, you know that it's a equals 0. Second degree, that means that I want my exponent to equal 2. Okay, so I want to have x squared over 2 factorial. Now, my function, and my a equals 0 is right here. My first function is 1 over the square root of x plus 1. I'm going to use a little bit more paper here just because your derivatives are going to be a little harder. We can't take the derivative when it looks like this. We take the derivative when it looks like this. X plus 1 to the negative 1/2. So I'm going to do the derivative over here, and then I'm going to write the function in my function line. Because you could also do this on scrap paper if you want your paper to look prettier. But your first derivative is going to be negative 1/2, x plus 1, and then negative 1/2 minus 1 means that you're going to go to the negative 3/2. Okay? Now, I need to evaluate this thing at a equals 0. Well, I know that here it's not so bad, but what if a was equal to 1 or 2 or 3 and I had to evaluate this thing? I need to put it back as negative 1 over the square root of x plus 1 cubed. And I gotta have that 2 out there as well. Okay? Now, this is what I'm going to use to evaluate. However, this is what I'm going to use to find the derivative. Okay, so I'm going to go ahead and find the next derivative. So negative 3/2 times the negative 1/2 is a positive 3/4 times x plus 1. Negative 3/2 minus a 1 is a negative 5/2. So my second derivative is a 3/4, so a positive 3 over 4, and then a square root of x plus 1 to the 5th. I don't need that parenthesis there. Okay. All right. Now, I should be good to go with my second degree. If I need another one, then I can do another one, but I'm going to kind of stop right there. Now, I'm plugging in a 0. Well, if I plug in a 0, 0 plus 1 is just 1. Square root of 1 is 1. So this just comes out to be 1. Well, now let's plug in this one. If I plug in a 0, now it's going to be a 1. Square root of 1 is 1. 1 cubed is 1. So these radicals, they're all just going to be 1. So this will be a negative 1/2. And this one, since this radical is 1, this will just be a positive 3/4. So there's my first term, first coefficient, second coefficient, third coefficient. Remember, you always start at 1. Then you have x. Then you have x minus a, so just x squared over 2 factorial. Okay? So here is our equation. F of x is approximately, well, 1 times 1 is just 1. Negative 1/2 times x is negative 1/2 x. This is a positive 3x squared over a 4 times a 2 factorial. Now, you've got your x squared, which is what they were looking for, second degree. Essentially, you are done. Here's the deal. If this were a multiple choice, they might simplify this a little bit if they could. 2 factorial is 2 times 1. So really you're saying 4 times 2 times 1. So they could say that this is 1 minus 1/2 x plus 3x squared over 8. Okay, so if they were simplifying the problem, then that's what they could do. Now, do they always? No, but sometimes they do. If it were multiple choice, for sure they would. Now, would they count this wrong if you left it on a free response? Of course not. You've done the Maclaurin process. You've plugged in all the values. You've got to the second degree. You're good to go. You can stop right here. And you're going to see in my homework when we go over the answers and stuff that sometimes I leave them and sometimes I don't. It just depends on whether I have a calculator or not. This next one that we're going to be doing, I'm just going to leave it. I'm not going to simplify it. So you'll see the difference between the two. All right, let's look at number 4, last one for today. Number 4, we're going to write the Taylor polynomial. So now we're going to see what happens when we're not centered at 0. Of third degree, so we're going to go to x cubed. For the equation, f of x is equal to the square root of x, centered at x equals 4. Well, I guess they'll say a equals 4. So let's say a equals 4. Okay, so it's centered at a equals 4. All right. Excuse me. So we got to start up our function. So we've got our function in our chart. We have a is equal to 4 this time. So all the other times we've had a equals 0, but for this one we've got a is equal to 4, so it's going to change it up a bit. Your function is the square root of x. Okay, that's our function. What's the derivative of the square root of x? Well, that's 1 over 2 the square root of x. Okay, so here's my first one. So then I'm going to take the derivative of that. Well, I don't usually take the derivative of that looking like that. I usually rewrite it to 1/2 x to the negative 1/2. So I'm writing it over here so that I'm actually able to take the derivative of it. Okay, so the derivative is negative 1/4. X to the negative half minus 1 is next to the negative 3/2. So this becomes a negative 1 over 4, the square root of x cubed. Now, remember, I'm going to be plugging in a 4, so I can't plug in a 4 having it look like this. I need to plug in a 4 having it look like this, which is why I've got 2 different pieces. Now, I think I need one more. So the derivative of this, a negative 1/4 times a negative 3/2 is a positive 3/8. A negative 1/3 minus 1 is a negative 5/2. So I have a positive 3 over 8, the square root of x to the 5th. Okay, so that's my third derivative. All right, so there's my function, my first derivative, second derivative, third derivative. So I've done all the derivatives, and like I said, sometimes the derivatives get a little tricky, but just do them to the side or do them on a scrap sheet of paper, and do them with your exponents the way you know how to do derivatives, and then just rewrite them over with the radicals, because you do have to plug in now at this point a 4. Now, when you plug in a 4 to the square root of x, what is the square root of 4? It is 2. Now, you're going to plug it into this one. Well, if you plug in a 4 down here, you've got 1 over 2 times the square root of 4. So that's 1 over 2 times 2, so that becomes a 1/4. Now we go to the next one. You plug in a square root of 4. Square root of 4 is 2. 2 cubed is 8. 8 times 4 is 32. So we have a negative 1 over 32. Then we're going to do the next one. Square root of 4. Square root of 4 is 2. Then 2 to the 5th is 32. 32 times 8 is 256. So we have 3 over 256. All right, so now these are all of our leading coefficients. numbers. You've got 2, 1/4, negative 1 over 32, and a positive 3 over 256. Now we fill in all the other pieces. The first one is just 1. The next one is x minus a. Now notice the a isn't 0 anymore, so we have to pull in x minus 4. The next one is x minus a squared over 2 factorial. The next one is x minus a cubed over 3 factorial. Now we're done because they told us to go to the third degree. So remember, you can't just leave it in your chart. This is your first term, your second term, your third term, your fourth term. So f of x is approximately 2 times 1 is 2, plus 1/4 x minus 4, minus a 1 over 32 times 2 factorial, x minus 4 squared. Now notice I didn't multiply those. That would just be 32 times 2. So you could do it. It's just, why bother at this point? Unless it's a multiple choice and you have to try and figure it out, I would just leave it. And then you have a plus 3 over 256 times 3 factorial times x minus 4 cubed. And now you've got your third degree. First term, second term, third term, fourth term. And you are done with your Taylor polynomial. Okay? All right, so that finishes our notes for today. Taylor-Maclaurin series homework, I'll post that as well so you can take a look at that. There are only 4 problems to do. Only one of them is centered at 0 because that's the easy one. And then 3 of them are going to be centered at different points. So you're going to have to do a little bit of work. They're going to be more like example 4 to get some practice. I have another neat thing that we'll look at, but we'll look at that a little bit on down the line, just to save some time because we're already at 30 minutes. All right, I hope you guys have a great day.